Okay, so today what we are going to do is convert between exponentials and logarithms, and then we're going to use that to solve. So remember that exponentials and logarithms are inverses, which means we have the ability to convert between the two. So these are the forms that we're looking at. Now, they might be written the opposite way, like b to the x equals a. Or x equals log base b. All right, so first thing we want to do is identify a, b, and x. Now, if you need to write this out, you can. If not, that's completely fine. So we can see here that we're starting with an exponential because we've got an exponent. So a is the number on the opposite side from our exponent, which in this case is 32. B is our base. So that's the thing that the exponent is being raised to, or that is being raised to the exponent. That's 2. And x is the exponent. So in this case, that is 5. Now, when we go to a logarithm, we're always going to have the word log. And depending on exactly what we've got, we'll just have different numbers or symbols in there. So b is our base. It's our little subscript. A is the number inside the parentheses, which is 32. Two. And x is our exponent. The original, for the log, it's what the logarithm equals. So in this case, it equals 5. And that's it. For number 2, this one starts with a logarithm. A is the number inside of the parentheses, which is 144. B is our base, which in this case is x. And x is the 2. So that x in blue is our variable. The x that's in black is just part of the formula. So even though they're the same variable, or they're the same letter, they are representing different things. Now that we have all of the parts of our formula defined, we're going to plug everything in. So A equals B to the x. And you can see from right here, this is why converting between the two is helpful, because if we wanted to, we could take the square root of both sides and solve for x. So we're going to do that later in this video, and just that's what it's used for. Now, sometimes with logarithms, you won't have the base explicitly given to you. So if we have log as in our common log, the base is 10 if there's no base given. If it's the natural log of whatever, the base is e. So e is a number in the same way that pi is a number. It goes on forever. And so we decided on a symbol for it. That symbol is e. So it's like 2.718, and it just goes on forever. So in number 4 here, we can see that there's no base given right there, which means, there we go, that our base is E. A is inside of the parentheses, and x is what the log is set equal to, which in this case is 1.09. We're going to turn this into an exponential. We have a equals b to the x. Similarly with number 5, we don't have a base given. This one is a common log because it's written out log as opposed to ln. So since there's nothing there, it's a 10. A is inside the parentheses. X is what the log is equal to. In this case, that's 2. And then we've got A equals B to the X. Last 2, and then we'll start working on solving. So for an exponential, it's A equals B to the X, so A is 9. B will always be given when it's in exponential form first. It's 3. And then X is 2. We're converting it to a log. Base 3 of 9 equals 2. last one. So we can see in this one it's not written in the same order. It does still do the same thing. So this time A is over here on the right. So when we're looking for A, we're looking for the thing on the opposite side of the exponential part. So if you see the part with the exponent, we want the thing that's on the opposite side. In this case, that's 512. B is the thing that is being raised to the power of whatever, in this case x plus 2, and x is the exponent. So we've got log base 8 of 512 equals x plus 2. Okay. And there we are. Now we could have solved a couple of these, like we could have solved this one or this one, but all that we were asked to do was convert. So if you see, instructions aren't up here, but if you see the word convert, like convert the expression, then all you're doing is conversion. When you're solving, it's going to have the word solve there. Okay. So what we're going to do now is solve some logarithmic and exponential equations. So we're going to start by doing the exact same thing that we were before. And if you don't have to write this part out, that's perfectly fine. So A is that 512. B is 8. And x is the exponent. So log base 8 of 512 equals x plus 2. Okay. So if you have a graphing calculator, there is a, so here's where all the numbers are. And then over here, there's a log button. And then right below that's natural log. If we want to do a specific base, we press alpha, which is the green button up here. And then we press window, which is one of the gray buttons. And 5. And what that's going to do is get us log. It'll look like a little square with dashed sides. And we use the right arrows to move through that. So we'll put the 8 down where the base goes, arrow over to the right, and type in 512. And that gets us 3. So 3 equals x plus 2, subtract 2 from both sides, you get x equals 1. Now we do need to verify our solutions. Generally for today it'll probably be fine, but 8, the 1 plus 2 gives us 512. This one's good. 1 is our answer. Sometimes it won't because we can't have a negative base. So that can cause an issue for today. Over here on number 2, this is going to convert to, so we have base B, which in this case is x. A is 144 because it's inside the parentheses. And x is what it all equals, which is 2. So when we convert it to an exponential, we have a equals b to the x. So from here we're trying to get x by itself. So we're going to take the square root of both sides. Just from solving that, x could be either positive 12 or negative 12. However, because we can't have a negative base, our only solution is going to be at positive 12. So negative 12 is extraneous. Okay, number 3. This time we have a natural log, and there's no base explicitly given to us, which means that it's e. A is inside of the parentheses, that's x minus 4, and then it all equals 5. We're converting that to an exponential, so a equals b b to the x. All right, so we need to put e to the 5th into the calculator. If we press second and then the natural log button, that'll get us e to the power of, and then we just have to type in 5. So x minus 4 equals 148.413. Add 4 to both sides, and we get x equals 152.413. Double check our answer, natural log, and then if we push second answer, that'll get that whole thing in there, minus 4, and that does indeed equal 5. Number 5. This one's not ready to go right away. What we're going to have to do first is divide both sides by 2. So because we have another value that's being multiplied by our exponential part, we're going to have to divide by that 2. So 30 to the x equals 900. Here we've got b. X is our exponent, which in this case is actually x. And a is 900. So log base 30 of 900 equals x. So this one's nice because in this case, we just need to type in the log part, and whatever number we get, that's x. So alpha window 5, base 30 of 900, and that gives us 2. X equals 2, plug it back into check. So 2 parentheses 30, close parentheses to the second power is indeed 1800. So that one's good to go. All right, number 7. Might look a little wonky, but it's not any different. A is 8 over 343. B is 2 over 7. And x is x plus 1. So it is perfectly okay for us to have fractions as our base. We just can't have a negative value there. So we're going to convert this to a logarithm. It's going to be log base 2 over 7. Of 8 over 343 equals x plus 1. In our calculator, to get a fraction, we hit alpha, y equals, and then enter. So alpha Windows 5 to get the log, alpha y equals enter to get the fraction. And we get 3. So 3 equals x plus 1. Subtract 1. We get 2. Verify our solution. So 2 over 7 raised to the 2 plus 1, which is indeed 8 over 343. So that one's good. Number 6 is going to be advanced only, so I'm going to do that one in a different video. If